Assalamualaikum warahmatullahi wabarakatuh to everyone. Hi, I am Fazira binti Abdul Rashid, and today me and my group member will present about our smart garbage collector management system using IoT devices. Before I proceed, I want to introduce my group members. The first one is myself, Fazira binti Abdul Rashid. The next one is Nur Shuhada binti Abdul Razak. The third one is Nurul Izzian Shaza binti Cik Idrus. And the last one is Nur Shahira binti Wan Ahmad Sayuti. So to begin with the presentation, I will now continue with the architectural design part. So we have decided to choose two architectural designs for our system, which are the layered architectural style as well as the event-driven architectural design. So in this layered architectural style, you can see there are so many layers over here, and the first one is the user layer used in our system. Next one is the component UIC and UI process component UIC layer. The third one is the service interface, or we call it as SI layer, that consists of registration, request service, as well as report problem. And then the data access component layer that consists of customer, admin, as well as the garbage collector. The next one is the service gateway layer, which includes services as well as the residential area. And here on my right is three more layers, which are the security layer, the operational management layer, as well as the communication layer. So why we choose layered architectural style for our system? We find this architectural style suitable to our system as it fits a big system. As this system is big, so we decided to choose layered architectural style. Other than that, this architectural style also used to show the interaction between external user up until the inner part of the system. So here you can see the overall system that in our design. Other than that, this architectural style also consists of a hierarchy of layers. As you can see over here, there are so many layers, which is really suitable to our system as it is consists of different layers. Each layer will then provide services to the layer above it and serving as client to the layer below it. Other than that, it is also a very good technique to use as it supports the incremental development of subsystem in the adjacent layer. This is really helpful as if we make some changes in our codes, it won't affect the whole system. It just affects the layer adjacent to it. Let's say we make some changes in this layer, so it won't affect this whole big system, but it only affects the layer adjacent to it, which is the user layer or the service interface layer. This architectural style is also help to increase the reusability as it will produce a very low cohesion and high coupling system. So that's why we decided to choose this layered architectural style. The next architectural design that we choose for our system is the event-driven architectural style. So this event-driven architectural style is used to indicate the interaction between the GPS tracker and also the ultrasonic sensor, which play the main role of the system. This is to show the IoT part and how it actually reacts with our system. So we also choose this architectural style as our system involve IoT devices. We choose this architectural design because our main reason is because of its versatility. This event-driven architecture style will allow our SGCM system to be constructed in a manner that facilitates a greater responsiveness because this architecture design normalized to unpredictable as well as a nonlinear environment. This design is highly versatile and adaptable to different circumstances. Since our system using the IoT devices and it acted upon real-time basis, it is really suitable to use this architecture style, moreover at the sending and receiving signal part, as well as detecting the location of the garbage dumps area. This is because this architecture style is also inherently optimized with a real-time analysis. So in the event-driven architecture style for SGWMS using IoT devices can be seen through here. So here there are the GPS tracker part as well as the ultrasonic sensor part, and this is the event dispatcher. It will then detect location of the trash bin, detect the trash level of the trash bin, and then send signals to the controller. So I will now pass the floor to my members. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wana Syahira binti Wan Ahmad Saidi. My metric number 1517892. So today I will explain about use case diagram for smart garbage collector management system using IoT devices and also deployment diagram. So firstly we will start with use case diagram. So this is our visualization of use case diagram. So here we have 5 actors. Firstly is customer, collector, admin, sensors and GPS. So this is our system. In our system we have 8 use cases. Firstly is register profile, send feedback, send trash label, send trash bin location, track full trash bin location, generate route and print report. So first of all, customer will use the register profile and it is associated with the admin, and then customer can send feedback also associated to admin. And then for garbage collector, the sensor will send the trash level of the trash bin, and then garbage collector will get the trash level. GPS send trash bin location to garbage collector, and garbage collector track full trash bin location, and GPS will show the location. So GPS will generate route for a garbage collector so that they can collect the full trash bin. And then admin can print report for the system. Next is our deployment diagram for smart garbage collector management system using IoT devices. So here, this is our visualization of deployment diagram. So we have 4 nodes, and which is device, controller, server, and user. So firstly, we start with user nodes. So user nodes aim to visualize event from the system and react the user to the system either via using website or smartphone. Website for admin and smartphone for user. And then user node has 3 components, which is user management, bootstrap, and also user interface. User management component is connected to Bootstrap, which will show the design to user interface. And user interface will display the interface of the system to the user. So next is controller. Controller is connected to server and also the device. First of all, it contains three components, which is track full trash bin, send trash bin location, and print report. So to track full trash bin, we use sensor, and then to send trash bin location, we use GPS tracker, and print report, we use website. So for why it is connected to server, when we send trash bin location, Google Maps server will send the location, and to print report, the database server will download and print the report. So next is a node server. So in node server, we have three components, which is database server and Google Maps server, and also server management. And the server management is connected to the database server and Google Maps server. Server management is associated with user management in user node, because when they need the information from the server, and the server management will get the information from the server nodes. And next is devices, device nodes, which consists of GPS tracker, sensor, website, and smartphone. GPS tracker to track the location of the trash bin, sensor to send the level of the trash bin, website for admin, and the smartphone for user. So that's all for use case diagram and deployment diagram. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Izyan Shazia binti Cui Idrus, metric number of 1512420. So I will explain about the logical viewpoint of our project about the class diagram. First of all, I will start with the sensor controller class. This sensor controller class is actually getting the trash signal from the trash bin. This signal is then sent to the sensor controller to check the trash level of the trash bins, and then send the signal to the trash controller. Trash controller class is to verify whether the signal of the trash level from the sensor controller is true or not, and then it will update the status of the trash level that is getting from the sensor of the trash bin, and then send the status to the signal control panel. GPS class is actually to get the location and also the route to the householder house. This location of the trash bin and also the route is get from the Google Maps server, and then sent to the location controller to verify and update the route and also the trash bin location, and then send the status to the signal control panel. The signal control panel is actually carried all the information from the trash controller and also the location controller. It will verify the location and also verify the trash level status and then send all the information that it got to the status control panel. This status control panel is then verify and update all the information and then send the status to the administrator. Administrator is then verified the status of the information of the trash level, the route, and also the trash bin location, and then update them and also send it to the trash collector. The trash collector and then will collect the trash based on the information that he get from the admin. After he collect the trash, he will report it back to the status control panel that he is done with the collection. And then the status control panel will receive the report status and then will see in the system that the trash bin has been emptied, and then the system is all done after the message has been received. That's all for the class diagram. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fazira Linda Abdul Rashid, and now I will present about the package diagram of the Smart Garbage Collector Management System. As you can see over here, there are overall 6 packages that we included in the system. So the first package is the sensors package. In this package, it includes the sensors that we use in the system, which are the GPS in order to detect the location of the trash bin, as well as the trash level sensors to detect the trash level in the garbage. So the next one is the controller package. In this package, there are 3 controllers that we use in the system, which are the sensors controller, the trash controller, as well as the location controller. The next package that we use is the control panel package. In this package, there are 2 control panels that we use, which is the status control panel. This is to show either the trash had been collected or not, and the next one is the signal control panel. This is to show the level, the signal that are being sent by the trash bin, if the trash level had come to the level that is needed to be collected. The next package that we use over here is the operation package. There are a few operations that is being done in the system. Among them are get trash signal. The next one is the get trash level. The next one is the get route. The fourth one is the get trash bin location. The fifth one is the get location. The sixth one is the get status, and the final one is the get signal. So all this operation is being done by the previous 3 packages, which are the control panel package, the controller package, as well as the sensors package. So the next package that we introduce in the system is the actors package. In this package, it shows the actors that involved in this whole system. Among them are the garbage collector, the administrator, as well as the client that use our system. So the result of this one big package, it will then produce a package that we call a garbage collection package. So this is kind of a result from the overall operation over here. So then we will get, the first one is the status trash bin, to see either the trash had been collected or not. The second one is a status trash level, to see the level inside the trash bin. Does it have been emptied or not? And the third one is the report to show for the garbage collector to mark when they have finished collected the garbage. The fourth one is the message. This is for the client. If either they want to make any complaint, if they are unsatisfied with the services or whatever. And the last one is the collection route. From the location that we get from the GPS, it will then do some sort of calculation to make a suggested route, so that it can optimize the cost and for the betterment of the system. So that's all from me. Thank you.
Bismillahirrahmanirrahim. My name is Nushu Haida binti Abdul Razak. So I'm going to present about a process viewpoint, which is activity diagram. Activity diagram is another important diagram in UML to describe the dynamic aspects of the system. Activity diagram is basically a flowchart to present the flow from one activity to another activity. The activity can be described as an operation of the system. The control flow is drawn from one operation to another operation. So this is our activity diagram for smart garbage management system using IoT. Basically, our system are focusing on 5 actors, which are customer, admin, sensor, garbage collector, and GPS tracker. Okay, so first we go to the customer part. Okay, as for the starter, customer need to register any new customer. They can use our system by logging them as customer, and then they can send feedback, write feedback, send rating, and as well as view report. Okay, so when they register, they will validate system will validate their username and password, and if they are registered, they can log in and proceed to the next activity. Okay, so for admin, they can log in as admin, then validate username and password, then log into the system. As well as the customer, admin also can view report summary and print report. They also can view the feedback that have been sent by the customer. Okay, so next one is sensor. This is the main part for our system, which is sensor is used to detect level of trash in trash bin. Basically, the sensor inside the trash bin will detect whether the trash is full or not. If full, it will go here, and at the same time, GPS tracker will detect the location of the full trash bin. So after that, the system will generate the route for the garbage collector to collect the trash. Depends on the route that have been generated. So then after they take action, and so they can report status, and the status can be viewed by the customer and the admin.
Hi, I'm Isian with metric number 151240. So I will explain again about the activity design of our project based on our class diagram. I just explain about the trash collector class diagram. This trash collector is used the method created inside a method. This is to make the object eligible for the trash collection. The modifier of this class is public. The input for the class is trash bin ID, and the output is trash collected. This method is called inside the stack frame. When the method is popped out from the stack, all of its members dies and it will create some object inside of this object to become unreachable or any anonymous after the method execution. So it will eligible for the garbage collection. That's all. Thank you.